Mars is silent. No oceans, no movement, no sign that anything ever lived here. Just dust and a surface that hasn't changed for billions of years. From orbit, it looks dead, completely lifeless. But recently, we found something buried inside it. Not fossils, not bones, not creatures frozen in time. Something smaller, something easier to miss. Fragments of ancient chemistry hidden inside Martian rock. The kind of chemistry that on Earth became life. And that changes everything. Because this is not just about what we found. It's about what Mars once had. Rivers, lakes, an atmosphere thick enough to hold heat and water in place. For a long time, Mars looked like a world where life should have begun. But here's the problem. It didn't. There are no clear signs that life ever existed here at all. No fossils, no remains, no proof that anything ever crossed that line. So now the question has changed. Not, did Mars have the right conditions? But something far more unsettling. Why didn't life happen, even when everything was there? The evidence didn't come from orbit, not from satellites mapping the surface. It came from something much slower, something much smaller, a machine moving inch by inch across an ancient lake bed. NASA's Curiosity rover has been exploring Mars for over a decade, drilling into rock, grinding samples into powder, looking for something that most missions never found. Not water, not ice, but chemistry. And recently, it found something new. Hidden inside rock billions of years old were organic molecules, not just simple carbon, but more complex structures. Chains of atoms linked together in ways that on Earth are closely tied to life. These molecules were locked inside the rock, protected from radiation, preserved like fragments of a process that never finished. At first glance, this might not seem extraordinary. Organic molecules can form without life. They can be created by chemistry alone, in space, in comets, even in cold, lifeless environments. But this is different, because these molecules were not drifting through space. They were found in a place that once held water. A place that once had the conditions life depends on. Which means this wasn't just chemistry happening anywhere. This was chemistry happening in a world that should have taken the next step. And that changes what this discovery means. Because now, we're not just looking at what Mars contains. We're looking at something else entirely, something more unsettling. A world where the process may have started, but never finished. To understand what was found on Mars, we need to be careful with one word: organic. On Earth, that word means life. Plants, animals, cells. Something alive. But in chemistry, it means something much simpler. Carbon. Atoms linked together into chains, into structures. into the kind of molecules that can become something more. That's what curiosity found. Not life itself, but the ingredients. On our planet, those same ingredients once existed long before anything was alive, floating in oceans, drifting in the atmosphere, reacting slowly over millions of years, until something changed, until those molecules didn't just exist, but began to organize, to replicate, to evolve. That step is where everything changes. Because forming organic molecules is not difficult. The universe does it everywhere, in deep space, inside comets, even in cold, lifeless clouds between the stars. But turning those molecules into life is something else entirely. It requires stability, time, the right environment, held together for long enough for complexity to build. And Mars, at one point, had all of that, which creates a problem. Because if the ingredients are common, and the conditions once existed, then something else must be missing, something deeper than chemistry. Something that determines whether a world stays lifeless or crosses the line. Because having the pieces is not the same as starting the process. Mars was not always like this. Not always silent, not always frozen. There was a time when water moved across its surface, not as ice, but as liquid. Rivers carved through the ground, branching, spreading, flowing for thousands of miles. Lakes gathered in deep basins, sitting still for long periods of time. Long enough for chemistry to settle, to build, to interact. This was not a brief moment, not a single event. These conditions existed for millions of years, possibly longer. And above it all was an atmosphere, thicker than what we see today, dense enough to hold heat, to protect the surface, to allow water to remain stable. From a distance, it would not have looked like the Mars we now know. It would have looked familiar, a world with clouds, with weather, with a surface where chemistry could move freely. And that's what makes this so difficult to explain. Because life on Earth did not appear instantly. It took time. It took the right conditions held together for long enough. Mars had those same conditions: water, energy, chemistry, time, everything that should have allowed life to begin. And yet, when we look back at Mars today, we don't see the result of that process. We see something else. A world where everything was in place and nothing happened. If Mars had water, if it had time, if it had the chemistry, then something should have happened. On Earth, it did. Life didn't wait. It didn't hesitate. It appeared. And once it began, it spread. From the first simple cells, to oceans filled with organisms, to a planet that would eventually become alive in ways we still don't fully understand. But on Mars, that chain reaction never came. There are no clear fossils, no preserved microorganisms, no chemical signatures that point to biology. Just silence. And that creates a problem. Because this isn't about what Mars lost. It's about what never began. One possibility is that life did start, briefly, quietly, but was erased before it could take hold, destroyed before it could leave a trace. Another possibility is more unsettling, that life never started at all. That even with the right conditions, even with time, even with chemistry, the step from non-living to living never happened. And if that's true, then something about that step is far more difficult than we thought. Because it means that planets can look habitable, can behave like Earth, and still remain completely lifeless. It means the process is not guaranteed, not automatic, not inevitable. It means that somewhere between chemistry and biology, there is a barrier, an invisible threshold that Mars never crossed. And we still don't know why. If Mars failed, then what does that say about everything else? For decades, we've searched the universe for planets like Earth. Worlds in the right place, with the right temperature, with the right chemistry. We call them habitable. But Mars forced us to rethink that word. Because Mars was habitable. It had water, it had energy, it had time, and still, it may have remained completely lifeless, which means something important. Habitability does not guarantee life. It only sets the stage. The real question is not, can a planet support life? It's, will life ever begin? And now, that question feels much harder to answer. Because if the step from chemistry to life is rare, then most of the universe could be filled with planets like Mars. Worlds that never came close, worlds that almost worked, worlds that had everything except the one thing that matters, life, which changes how we look at our own planet. Because Earth didn't just form in the right place, something else happened here. Something we still don't fully understand. A transition from lifeless matter to something that could grow, adapt, evolve. And if that transition is not common, then Earth is not just special, it may be exceptional. A world that didn't just have the chance, but somehow crossed the line. Mars is still there, unchanged, a frozen surface holding the memory of something that almost happened. We found the chemistry, we found the conditions, we found the time, but not the result. Not the step that turns matter into life. And that may be the most important discovery of all. Because Mars didn't just show us what a dead world looks like. It showed us how easily a world can fail. How close a planet can come and still remain silent. Which means when we look at Earth, we're not just looking at a place that works. We're looking at a place that somehow crossed a line most worlds never do. Join us next time as we explore more mysteries of the universe.